All right, this is going to be my last video this morning, and I'm going to give you an example of another hypothesis test. And I decided I'm just going to use this is the exact exam question I used in the spring, so I'll give you a different question, but the format will be very, very similar to this. Um, so the setup is recent data tells us that users of social media in the US average 144 minutes per day. Suppose a high school has tried to get its students to use social media less. After a year-long campaign, the school samples 42 students. The sample has a mean use of 128 minutes with a standard deviation of 38.2 minutes. So I'm just going to take a moment and just highlight some important stuff. Really what we have here is if you look at this 144 minutes per day, what this really is just a past piece of knowledge. Like in the past, we've understood it to be 144 units per day. So this is going to be a major player in this is that this is going to be the assumed population proportion. When we get to writing the hypotheses, we're just going to assume students at this high school use social media the same amount as the US average. The other one is then use the social media less. That's going to tell us some information about the alternative hypothesis. And then the school samples 42 students and they find a mean of 128 with a standard deviation of 38.2. So what we've got here is our sample size of 42, our sample mean of 128, and our sample standard deviation. And again, I'm going to say sample standard deviation because that's important. That's going to tell us that this is going to be a t-test as opposed to a z-test, and we're going to use the t-distribution to find our probability. So that's kind of the main information. So the first one is check to see if the sample is sufficiently large. Well, that's pretty easy because 42 is more than or 30, and as long as our sample is greater than or equal to 30, then we've got the go ahead to proceed and use the normal distribution and write the appropriate hypotheses. Let me just lower this a little bit to start to do this. This is really going to say our base assumption is going to be let's start just by assuming that the mean time that students at this high school spend on social media is the same as the rest of the United States. But what the school is hoping is that the mean time is less than that, that they've successfully got their students using social media less than the national average. And I would guess that the natural average for all adults is less than what it is for teenagers on average. So I think if the school got below 144, they'd be doing really well because I imagine the mean for teenage use is probably higher than that. But either way, we've got those are our hypotheses, and this literally reads null hypothesis. The mean is 144. This would mean those high school students use, on average, social media 144 minutes a day. An alternative is that these high school students are using it less than that. So the next thing it says calculate the standard error. Because this is a quantitative variable, the standard error formula we're going to use is going to be that s over the square root of n. And we were told that the S was 38.2 minutes, and our sample size was 42 students. So that calculation would be 38.2 divided by the square root of 42. I recommend you do these calculations along with me. And I'm going to round this to 3 decimal places, 5.894. That would be the standard error. Uh, and then it says calculate the test statistic. That term basically means t-score or z-score. The reason I use test statistic is I didn't want to hint that or tell students that this was a t-distribution. I wanted to figure them out on their own. So if I'd said find the t-score, that would have been a giveaway. But in general, the t-score for this is going to be the same formula we've been using, that data minus mean divided by standard error. And in this case, our data is our sample mean. The population mean would be that value we assumed it to be, 144. Just filling these numbers out a little bit, we've got these particular students had a mean of 128. We're assuming a mean of 144, and we just found the standard error to be 5.894. So in other words, you can just kind of see that, what's that, about 12, 16 minutes less on average. And so if we do 128 minus 144, that's negative 16. Divide that by 5.894, and that gives us about negative 2.715, and that's a rounded number. So this is a necessary step when you're doing hypothesis tests for quantitative variables, and you're working with a sample standard deviation. So on the test, I will give you a chance to walk up to a computer. There's going to be a number of computers in the front, and this would be the one time that you could use StatCrunch on the test. You would just walk up and you would go, all right, I'm using the T calculator. The degrees of freedom in this place, this is a sample size of 42, so it would be 42 minus 1. And we are curious, less than is appropriate, and our t-score was negative 2.715. All right, so what we're showing here is that is the p-value, and it's 0.0048. I'll write that down, switch back over. We found that p-value was 0.004, and I already forgot it, but I'm going to go over at it. 48. That's what I thought it was. So that is less than 1%. It's pretty close to 0.5%. So I'm just going to go back to the front. It says, is this sufficient evidence to show the mean daily usage of social media by students at this high school is less than the US average? Conduct a hypothesis test at the 1% level of significance. So that 1% is the number we're going to compare this to. That 0.0048 is less than the level of significance. And what this means is we can reject the null. And it helps to look at the null and say, like, all right, reject the null. We have just shown that we don't think the average at this high school is 140 minutes, so we actually can support the alternative. And I think the next question is, what does this conclusion mean in the context of this situation? And this would mean our sample provides sufficient evidence to show that the mean time students spend on social media at this high school is less than 144 minutes. We rejected the null, so that's sufficient evidence to show that the mean time students spend on, so it basically is saying sufficient evidence that whatever your alternative hypothesis test, if we had failed to reject the null, a good way to write the sentence is just the same sentence. You would just say, our sample does not provide sufficient evidence, ... and say the exact same thing. And we haven't in class talked about type 1 and type 2 error, but really has to do with, so in this scenario, that p-value of 0.0048 means there's about 0.5% chance that we're wrong, right? So an important part of doing this is saying these aren't absolutely certain. When you do a hypothesis test, it might come to the wrong conclusion. And so it's important to just anticipate what impact you might have, and that might affect how you run your test, about where you set your level of significance. So in general, if when you reject the null, you're automatically at risk of a type 1 error. And when you fail to reject the null, you're already at risk of a type 2 error. So in this case, we're at risk of making a type 1 error. All you have to remember is if I reject the null, I'm at risk of a type 1 error. And that's where the null is true, but you rejected it, and you were wrong to reject it. So we'll talk more about that in class next week, but that's just a quick introduction to that. All right, I hope you all have a good weekend. That's my contribution for the day.